Hi children, now we are into part 2 of metals and non-metals. Okay, here in the part 2 we are discussing about chemical properties of the metals. Okay, in the chemical properties of the metals mainly we are discussing about how the metals react with oxygen, that means with the air, and how the metals react with the water, and how the metals react with dilute acids. We are going to understand in this topic. Okay. Now first let us see how the metals react with the oxygen. Oxygen is nothing but from the atmospheric air. Okay. Now if you take the general equation, metal plus oxygen gives rise to metal oxide, which is nothing but basic oxide. Generally when metals react with the oxygen, they produce metal oxides. Those metal oxides are basic in nature. Okay. But all the metal oxides are not basic. Some cases, some metal oxides show both the properties acidic as well as the basic. Once the topic comes, I discuss about that special category. Okay now? Now let us see. If you take the example of sodium. Sodium when react with the oxygen, it gives sodium oxide. The sodium is highly reactive. It reacts vigorously, very rapidly with the atmospheric oxygen. It reacts and produces sodium oxide. The same way with potassium. Just at the room temperature, it reacts with the oxygen the same way how sodium reacts and gives out potassium oxide. These two, when these two again dissolve in the water, they produce here sodium hydroxide. The sodium oxide with the water, it gives you sodium hydroxide. Similarly here also, when it reacts with the water, this also gives potassium hydroxide. And these two generally dissolve in the water. Sodium oxide and the potassium oxide dissolve in the water, produce hydroxides of those metals. That's why these are called alkali metals. What do we call? Alkali metals. Okay. Now come to the third category. Next metal, aluminium. This aluminium reacts with the oxygen, but at the normal conditions, just simply in the atmosphere, if you keep the aluminium won't react with the oxygen in the atmosphere. Okay, but it reacts on heating. Aluminium reacts with oxygen on heating and produces aluminium oxide. The same case even with the zinc. Okay, here this aluminium oxide as well as this zinc oxide. These two oxides of the metals show the properties similar with acids as well as the bases. Here if you take this sodium oxide, and this sodium oxide is basic in nature, and the sodium oxide turns the red litmus paper into blue color. Similarly, this potassium oxide also turns red litmus paper into blue color. But when it comes to this aluminum oxide and the zinc oxide, this aluminum oxide reacts with acid and produce salt and water. Similarly, this aluminum oxide reacts with sodium hydroxide and produces salt and water. And children, in the previous acids, bases, salts lesson, we understood that when acid reacts with the base, produce salt and water. That is nothing but acid and the base. When two substances react each other, produce salt and water, those two are nothing but one is the acid, one is the base. Here, this aluminum oxide react with hydrochloric acid, produce salt and water. So in that case, hydrochloric acid, we know very well that is acid. Then here, in that case, it is acting as a base. And in the other case, this aluminum oxide react with sodium hydroxide. Sodium hydroxide is base, we know very well from this. And this aluminum oxide reacts with the sodium hydroxide, produces sodium aluminate and the water. So salt and water produced. That means sodium hydroxide is base, then ultimately it has to become acid. In the previous example, became as a base, here it is acting as an acid. That's why such type of oxides of the metals are called amphoteric. What do we call? Amphoteric oxides. Okay. How many we are having like this? Aluminum oxide and zinc oxide. These are the two oxides which show the properties sometimes as acid, sometimes as base. That's why aluminum oxide and zinc oxide are known as amphoteric oxides. Okay children? Now come to the next case. Iron also reacts with the oxygen. But you may get doubt, sir, how the iron reacts? If you take the iron material anything, it generally won't react. But when you take the iron filings, just like the powder of the iron, in the hot burning surface, if you drop them, the filings will catch the flame and those also will burn. But iron reacting with oxygen it is not that much easy. It takes long time for reacting and gives Fe3O4, which is known as ferroso-ferric oxide. Ferroso-ferric oxide. Okay? And copper also takes long time for reacting with the oxygen to produce copper oxide. Okay? This is also very prolonged. Okay? On heating for long time, this will be happened. Okay, children? Children, here magnesium also reacts with oxygen to give magnesium oxide. This magnesium generally won't react with the atmospheric oxygen. It takes long time for reacting, but when it is heated on a flame, it catches the flame and gives out the magnesium oxide. And this magnesium oxide, when we dissolve in the water, it won't dissolve completely, but somewhat it dissolves and it gives out magnesium hydroxide. Okay? Children, here now we see how the metals reacting with the oxygen. Okay? And some metals generally require some heating support, but some metals immediately react with the oxygen, very vigorously react with oxygen. Those metals are sodium, potassium and lithium. That is the reason these metals always store under kerosene. The reason is to prevent them from reacting with the oxygen. Okay? Here I am having the sodium metal with me. And if you observe, these all are stored along with the wax cubes. These are the wax cubes. Inside the wax cubes, sodium is placed. Okay, I took a small piece of this wax cube. Okay, if you leave it, it reacts easily with the atmosphere. But to identify its color and its flame and everything, I am just putting on the flame. The color of this flame we will understand now. Okay, and once its oxide is formed, we are going to check that whether that is dissolved in the water, and that once it is dissolved in the water, whether that will be showing the acidic property or basic property, that also we are going to check now. Okay, children? Yes? And which are the three metals generally stored under kerosene? Yeah, you are right. Sodium, potassium and lithium. These are very highly reactive. They react in the atmosphere, oxygen, and they form their oxides. Okay? And these are very highly exothermic reactions. Very highly exothermic reactions. Children, what is the flame of this color here? Yes, see, you can see that sodium metal, which is silvery color, shiny silvery color. Yes, and you can see the burning of sodium, beautiful yellow color. Are you able to see the color? Yes? Yeah, this is sodium. Okay, children? Yeah. And this is magnesium ribbon. Children, all of you know very well this magnesium ribbon. Generally, when it is exposed to the air, it forms its oxide. And when you try to burn it, it won't catch flame quickly. That is the reason the surface, the ends of this magnesium ribbon must be rubbed against a sandpaper to make it very shiny. Yes? Yeah. Now, let us see how it is catching a flame. Magnesium generally won't burn directly and won't react with the oxygen that much easily unless it is heated. And see the flame, and don't see the flame directly with your naked eye. It is not good. Okay? The magnesium burnt and produced magnesium oxide. And this ash I am collecting into a test tube here. I am just dropping this ash into the test tube, and I am just putting some water into it. Oxide into a test tube, and I am dissolving this magnesium oxide, and that solution is testing with litmus paper. Okay, I am taking few drops of water here. Yes, but magnesium oxide generally do not dissolve in the water easily. It takes some time. Okay, and that solution whatever produced, that whether it is showing the acidic nature or the basic nature, whether it changes changes the litmus paper from red to blue or blue to red, or how it changes we understand. Okay, and in the previous we burnt the sodium metal node here. So the sodium metal when burnt, it is produced sodium oxide. Yes, the sodium oxide also we are going to dissolve in the water. Small quantity of sodium oxide which is collected from the spoon. I am dissolving in the water. Okay. Yes, the solution prepared now. Now let us test. Children, this is the magnesium oxide dissolved in the water. Okay, and I am having two red litmus papers here. How it is going to change this litmus paper, we'll see now. Just we drop few drops of this solution. Okay, just we'll observe for some time later. Okay. Now here we are having even sodium oxide which is dissolved in the water now. Yes, this we'll just test. Children, see here, sodium oxide dissolves in the water instantly and forms sodium hydroxide. This red litmus paper changes to blue color. And here, regarding this magnesium oxide, when dissolved in the water, magnesium hydroxide, which is the basic in nature, slowly this is also changing into blue color. So from this what we can understand, sodium, potassium and lithium. These oxides dissolve in the water and they form hydroxides of those metals, which are known as alkali. And you know very well, alkali is nothing but the metal oxides when dissolved in the water, those are called alkalis. Okay, and magnesium oxide also dissolve a little. Okay, it is not that much strong like sodium or the potassium. Okay, and this also changing into the blue color. Yes, children, clear? Yeah. Come to the second case with water. Okay, so how the metals react with the water, we are going to understand now. Now, the general equation, when metal reacts with the water, it produces metal hydroxide and hydrogen gas. Metal hydroxide and hydrogen gas. If reacts with the water, suppose the same metal reacts with the steam, it forms metal oxide and the hydrogen gas. Children, is it clear? If it is reacting with the water, then hydroxide of the metal and hydrogen gas produced. When reacting with the steam, the metal reacts with the steam, gives metal oxide and the hydrogen gas. Here hydroxide of the metal produced, here oxide of the metal produced. Okay, now let us take the example. Now let us take the example of potassium. Potassium reacts with oxygen, water, and it is happened in the cold water, and that is very vigorously react. Very rapidly the reaction takes place and gives potassium hydroxide, hydrogen and enormous heat produced. Okay, and when you take small piece of potassium or the sodium and drop in the water, cold water, immediately that reacts and hydrogen gas evolves. This released hydrogen gas will catch flame because so much of heat is produced. That heat makes that hydrogen to burn and it catches the flame and sparkling can be identified. Okay, now after this we are going to see the equation reaction also. Yes, I think you are interested. Yeah, so either potassium or the sodium very vigorously react with the water and produce their hydroxides, hydrogen and the heat produced. Come to the calcium. Even calcium reacts with the water in the cold water itself and forms its hydroxide of the calcium and the hydrogen. Because when it is the water, we know very well hydroxide of the metal produced. If it is steam, then only metal oxide produces. Okay. Now let us see the example with the magnesium. Magnesium in two different ways. Magnesium generally do not react with the normal water, but reacts with the hot water, produces magnesium hydroxide and hydrogen. But the same magnesium, when reacts with the steam, it reacts even with the steam, produces magnesium oxide and the hydrogen gas. Here, with the hot water, hydroxide of the magnesium, with the steam, just oxide of the magnesium. And similarly, aluminium, zinc and the iron also react with steam and produce their oxides of their metals. Oxides of their metals and the hydrogen. Got it, children? Now, let us see one of the reactions of these. Yeah. Children, see this? This is sodium metal. Okay? I am dropping in the water. How it is going to react with the water, you can see very clearly. Okay? See the sound, the fumes and sound it is, and it rotating around the container. Yes, and so much of hydrogen gas is evolving here. So much of hydrogen gas evolves. And by the time when it is getting vanishing, you can find out even sometimes flames. Okay? Just let us understand how it is happening and all. Yes? And children, if you just hold the container, it is very hot, very hot. So much of heat produces here. Okay? Along with the heat, that hydrogen reacts and it catches the flame. Sparkling can be seen. Yes, are you able to see it is just moving randomly? Yeah. Children, now we understood how it reacts with the water. That sodium, how vigorously it is just moving in the container. Yes, that is the reaction. Everything will be taking place in the similar way for the sodium, potassium, even lithium. And these will be taking little time. And magnesium, if you take, or zinc, aluminum, or the iron, if you take, it takes long time for reacting. Only with the steam they react, and they produce their oxides and the hydrogen gas produced. And now let us come to the third case. Reaction of metals with dilute acids. Dilute acids. So here dilute acids, let us take the example of hydrochloric acid. Okay. So with hydrochloric acid, how it takes place, we'll see. The general equation is metal plus dilute acid gives you metal salt plus hydrogen gas. Okay. So best example, sodium, potassium or magnesium, whichever you take, these three react with the hydrochloric acid similar manner and gives you the salt of that metal. If you take the sodium, sodium salt. If you take the potassium, potassium salt. If you take the magnesium, magnesium salt, magnesium chloride produces. Okay. And here one more example. Aluminium also react with the hydrochloric acid to produce aluminium chloride and the hydrogen. But it generally takes time. Actually, this aluminium initially it will be covered with the oxide layer, which is nothing but the anodizing. Okay. This is one of the best processes for coating this aluminium onto some other substance. Any coating can be done on the surface, and this is the best method for this aluminium from preventing getting further corrosion by itself. Once aluminium is taken and if it is reacted with the oxygen and form the layer of aluminium, oxide of the aluminium on it, and it further won't get oxidized that easily. Okay, that helps for preventing from further oxidation. Okay, that is the reason initially this aluminium becomes little slower for reacting with the hydrochloric acid, and once the layer of that oxide is melted, then the reaction becomes quicker and hydrogen gas will be evolved. Okay, and zinc or the iron also react with the hydrochloric acid little slowly compared with the aluminum, still more slower, and by heating it will be taking little quicker and produces the respective salts. Okay, and when it comes to the copper generally won't react with the hydrochloric acid. The reaction of hydrochloric acid with the copper in the sense, in the previous lesson we understood, this copper is low reactive than the hydrogen in the activity series. That's why this copper cannot displace this hydrogen. That is the reason copper cannot react with the hydrochloric acid. Similar way, even sulfuric acid also will be showing the similar properties with this. Sulfuric acid also, in place of hydrochloric acid, only sulfuric acid will come. The similar reactions can understand. But when it is nitric acid, children, when it is nitric acid, you know HNO3? Yes, this HNO3 is very good oxidizing agent. Okay, when you take any metal and reacting with the nitric acid, this nitric acid generally reacts with the metals, but the end product is not the hydrogen. The reason is this HNO3 oxidizes the produced hydrogen and makes it water. And this nitric acid itself reduces to like dinitrogen oxide, otherwise nitrogen monoxide, otherwise nitrogen dioxide. Children, listen. This nitric acid, in case of sulfuric acid, the same situation happens like hydrochloric acid. But in case of nitric acid, the same way it won't happen. The metals, when react with the nitric acid, the end product is salt along with nitrogen oxide, nitric oxide or nitrogen dioxide. The reason is this nitric acid is best oxidizing agent. It provides the oxygen to the produced hydrogen. Okay, in the previous case what happened? Sodium reacts with the hydrochloric acid to produce salt and the hydrogen. So when you take the same sodium, in place of HCl, if you take HNO3, it gives you NaNO3, sodium nitrate, plus this hydrogen produces, no? This hydrogen further reacts with the oxygen from the nitric acid, it changes into water. Okay? Along with the water, it gives nitrogen dioxide or nitric oxide or nitrogen dioxide. Dinitrogen oxide, nitric oxide or nitrogen dioxide. It will be happened. Okay? Is it understood, children? I am taking sodium metal. Yes. And I am dropping few drops of dilute hydrochloric acid. Yes, are you able to see the bubbles? Yes, releasing of hydrogen gas. So we just saw the reaction between sodium metal and the hydrochloric acid. You have seen even that popping and everything, the burning and everything. No? Beautifully you have seen everything. Yes? So we have to be more cautious when we are doing the reactions in the classroom or in the laboratory. No? We have to be cautious. So when we are taking all the metals, the reaction with the dilute acids we understood. But what about the silver, gold and copper? They do not react at all. Okay? So with the hydrochloric acid, similar with the sulfuric acid it is happening. But with the nitric acid, when it is with the nitric acid, if you observe, sodium nitrate will be produced. But this hydrogen which is evolved will be oxidized to water. And along with that, oxide of the nitrogen, one of the oxide of the nitrogens will be produced. But it is different. However, it is different with the magnesium or the manganese. Magnesium or the manganese. If you take very dilute nitric acid, when those are reacting with this any one of these, in such cases, the nitric acid cannot oxidize the produced hydrogen. In this case, it cannot. It will not be able to oxidize that hydrogen. And here, as usual, hydrogen gas will be evolved. Okay? So if you take this one, in the presence of nitric acid, it produces magnesium nitrate and hydrogen gas produced as it is. There is no difference. But in general, if you take the other metals, this hydrogen further oxidizes to water. And the nitric acid, from the nitric acid reduces to nitrogen, but dinitrogen oxide or nitric oxide or nitrogen dioxide. Yes, got the clarity about this? Yeah. Now let us understand about aqua regia. Aqua regia. Aqua regia is nothing but a very special liquid which is having, we can say this is a holy liquid or special liquid we consider. This is having a special characteristic property that it can dissolve anything, even gold and the platinum also can be dissolved. So how it is prepared? Okay, so for preparation of aqua regia, 3:1 ratio of concentrated hydrochloric acid and concentrated nitric acid. The combination of hydrochloric acid and concentrated nitric acid in the ratio of 3:1 itself is nothing but aqua regia, generally used by goldsmiths and all in the purification of gold and the platinum and silver. Yes, children? Clear? In the next class we are going to understand about reactivity series and further.